You ever look at a massive oil refinery or some complex chemical plant and just wonder, how does that all work? How does it all fit together? Well, it turns out there's a hidden set of rules, kind of like a universal language that lets our entire industrial world even exist. Today, we're going to pull back that curtain and take a look at the Universal Rulebook that builds our modern world.
I mean, just stop and think about that for a second. The scale of the challenge is just immense. You've got thousands of different parts, pipes, bolts, valves, coming from hundreds of different factories in countries all over the globe. So how do you make sure that a valve made in Germany is going to fit perfectly and, more importantly, safely onto a pipe that was made in Korea? How do you know that whole system can handle mind-boggling pressure and crazy temperatures without failing?
Right. Without that common language, without a shared rulebook that everyone agrees on, you'd have absolute chaos. Parts wouldn't fit together, you'd have weak spots that could lead to catastrophic failures. Honestly, trying to build anything on a global scale would be next to impossible.
But we don't live in chaos. We live in a world with these incredible structures. And that's because we have a solution. It's a code called ASMEB31.3. And this is the hero of our story today. It's the universal rulebook that engineers all around the world depend on every single day. So what is this thing exactly? Well, to put it simply, ASME B31.3 is the master code for what's called process piping. And that's basically the intricate circulatory system of any industrial plant. This code is what lays down the law for how all those systems are designed, how they're built, and how they're tested to make sure they're safe.
Now, I'll be honest, if you actually look at the document itself, it can seem pretty intimidating. It is dense, it's super technical, and it's just jam-packed with these complex tables. But buried deep inside all that complexity is a core idea that is just brilliantly simple. One single decision that makes this whole system click. And that one single decision creates two very different paths for every single component that goes into a plant. It really is the core logic that the entire framework is built on. And this is it. This is the fundamental question at the heart of the entire code. It comes right from sections 326.1.1 and 326.1.2. For every single bolt, every valve, every piece of pipe, the engineer has to ask one simple question. Is this component listed or is it unlisted? And those two options create two very different paths. A listed component, that's the easy path. It's a part that's already been standardized, it's been tested, it's been pre-approved for safety, it's right there in the code's master catalog. But an unlisted component? Well, that's the hard path. It's something new, something custom-made that isn't on that pre-approved list, and because of that, it has to go through this whole rigorous process to prove it's just as safe. So the workflow is what's really key here. If you can use a listed part, you pick it out of the catalog. You grab it off the shelf, so to speak. You already know it's good to go. But if you need something special, something unique, you're forced down the unlisted path. You have to design it, run all the calculations, and perform a battery of tests to prove to the code that your new invention is safe enough. You know, this idea of a master list is just so central to how this all works. So let's actually take a look inside this library of pre-approved trusted components. In the code, it's officially known as Table 326.1. I love to call it the Library of Trust, because really that's what it is. It represents a shared global agreement on which parts are proven to be reliable and safe under really specific conditions. It just takes all the guesswork out of the equation for engineers. And here it is. This is a page from that very table. And as you can see, it's just listing out all these specific standards for thousands of different components. This table right here is what creates that universal language we were talking about, the thing that allows builders everywhere to be on the exact same page. And this list, it covers absolutely everything. It starts with the most fundamental building blocks you can possibly imagine, things like standard nuts and bolts, which are specified right here under ASME B18.2.2. But it's not just the simple stuff. It also covers way more complex and critical components, like these massive, heavy-duty steel gate valves, which have to follow the super strict rules of API 600. And of course, it covers the most vital parts of all, the very arteries of the plant itself. This is the standard for the steel pipe that has to carry all these materials, making sure its strength and its dimensions are perfectly consistent no matter where in the world it was manufactured. Okay, so we've got this incredibly detailed, maybe even a little obsessive rulebook. So what? Why does this all really matter in the real world? Let's connect these kinds of abstract rules back to something a little more concrete.
The impact is it's massive. First, and this is the big one, safety. It's the non-negotiable guarantee that every single piece can handle the stress it's going to be under. Then you get interoperability, that global handshake, right? The guarantee that parts will just fit. You also get incredible efficiency. Think of the countless engineering hours saved because people don't have to reinvent and retest every part from scratch. And maybe most important of all, you get trust. It creates a common foundation that allows these massive, globally sourced projects to even be possible in the first place.
So here's the bottom line. ASME B31.3 isn't just some boring technical document. It's an invisible blueprint. It's a global agreement on how to build things safely and how to build them right. It's the hidden code that is quietly preventing disasters every single day and allowing our entire modern industrial world to function. It really makes you think, doesn't it? What other invisible rulebooks are all around us, just quietly making sure our world works? I mean, from the electricity in our walls to the Wi-Fi floating through the air, our lives are literally built on these hidden codes. What do you think is another big one?